Which of the following contains an oxygen atom that has a formal charge of +1? So I recommend as you go through organic chemistry, that you get used to what some of the common elements that you're going to see over and over again in organic chemistry, what their bonding patterns are, so that you can instantly recognize when you have a charge on one of these common elements. So the common elements that I recommend that you familiarize yourself with, so common elements in organic chemistry, are hydrogen, carbon, oxygen, nitrogen, and the halogens. So things like bromine, chlorine, iodine. So in this question, we're being asked about oxygen. So we want to know what a neutral oxygen atom looks like. So oxygen has 6 valence electrons. And so it tends to get the extra 2 valence electrons it needs by forming covalent bonds. So a neutral oxygen atom is an oxygen atom that has 2 bonds and 2 lone pairs of electrons, is a neutral oxygen. So 2 bonds and 2 lone pairs. And so those bonds could be 2 single bonds, as we've drawn here, or it could be a double bond. So we still have 2 bonds and 2 lone pairs to the oxygen for C. So this is a neutral oxygen. So we don't have to consider that as an answer. And we should also recognize that option B also fits this bonding pattern. It has 2 bonds and 2 lone pairs. So this is also a neutral oxygen atom. So our other 2 options, A and D, are not following this bonding pattern. So we expect that we are going to see a formal charge on both of these oxygens. So if we want to calculate the formal charge, what we want to do is we want to take the valence number of electrons, which is 6. So we're going to take those 6 valence electrons, and we're going to subtract from that the number of electrons that belong to the oxygen in this structure. So what we do is we say that any non-bonding electrons, so those would be lone pairs, those electrons definitely belong to that atom. And then for each covalent bond, we're going to recognize that covalent bonds are shared electrons. So 1 electron from that bond belongs to one atom and 1 to the other. So if we are going to subtract from the number of valence electrons, the number of electrons that are on the oxygen in this structure, we are simply going to count 1 electron from each covalent bond, so 1, 2, 3, and then any lone electrons, so 4, 5. So here we have 4 minus 5, so this is +1. So we have actually found already our oxygen that has a formal charge of +1. For extra practice, though, we should go and look at our other structure that we said also does not fit this bonding pattern of a neutral oxygen. So let's calculate the formal charge of this as well. So the formal charge is again going to be the valence number, which is 6, and we're going to subtract from that the number of electrons on this structure, belonging to the oxygen. So any lone electrons and half of the bonding electrons. So for the bond, we count 1, and then 2, 3, 4, 5, 6, 7. So 6 minus 7. So this oxygen has a negative charge. So we want to familiarize ourselves again with what a neutral oxygen looks like, an oxygen with a +1 and a -1, and we want to do the same thing for the other common elements that we will see in organic chemistry. And we will not see these elements with charges greater than 1, either +1 or -1.